SmartCAM V17 builds on many of the previous SmartCAM releases, with specific improvements for SmartCAM milling applications and a broad range of core improvements that will improve the everyday use of SmartCAM for everyone. Introduced in version 16 of freeform machining, advanced milling, and advanced turning, the solid pocket process has been enhanced to include several new capabilities which expand the types of pocket features it can be applied to and improves both the machining efficiency and cycle time. We will begin by demonstrating how pockets with slots or other types of wall interruptions can now easily be machined using the SmartCAM solid pocket process. This pocket contains slots on each end. Previously, the solid pocket process was capable of generating toolpath only for the final depth level, since a completely closed boundary created from slicing the model was required. We will use the Group Tangent Surface Selection method introduced in a recent SmartCAM release to automatically select all the surfaces representing the pocket feature, and then select the top face from which the pocket begins. We will use a bull end mill to perform the roughing operation. On the solid pocket panel, we specify a width of cut, a depth of cut, and a 3D finish allowance, and choose Go to automatically generate the toolpath. We'll change to an end view of the component to see the levels that have been machined. Note how all depth levels are cut, including those spanning the slot feature. Let's show how it is now possible to generate multiple depth levels for a pocket, starting from an elevation above the pocket. This capability is especially useful when there is additional stock on the top face above the pocket, for example if machining the pocket prior to another process, or from a rough casting with excess stock. We will select and modify the solid pocket process, and recall the panel and settings used to create the toolpath. Process containers make it easy to recall the process with all the parameters used to create the toolpath, modify those parameters, and then regenerate new toolpath based on those modifications. We'll turn on the Start Z level and specify a new start level above the top of the part and regenerate the toolpath. Note the additional passes generated above the model. Let's use another model to show the usefulness of this capability. Notice how this model has non-planar top surfaces above the pockets to be machined. In the previous solid pocket process, only the depth levels that formed closed boundaries when sliced could be machined. With version 17, as long as there is a closed boundary at a lower level of the pocket, all upper levels of the pocket can be cut using that lower boundary. We select an end mill to perform the roughing operation. Using the same cut parameters we used on the previous model, we'll machine the pockets. We will turn off the user-specified Start Z level, then hit Go to create the toolpath. Note how the pocketing toolpath is generated even for the upper levels that would have resulted in open boundaries when sliced. Now we will demonstrate the new capabilities for machining pockets with islands and shelves. As you can see, this model contains a number of shelves and several islands at various depth levels. In previous versions of Solid Pocket, horizontal surface critical depths could be automatically detected and cut. However, when using this feature, the entire pocket region was cut for each depth level, which in cases such as this model would result in cutting several depths at very small increments, making machining time overly long. We will turn model transparency on in order to easily view the closed depth increments between levels. In version 17, when detecting critical depths, users may choose to either machine the entire level as before, or to restrict the cuts to the critical face region. Restricted critical face machining can be sequenced before or after the next depth level. To see how the new process saves machining time, we'll estimate the machining time of the previous pocket machining process, which cuts the entire level for each critical depth, then do it again later with the new process. We will use ShowPath to do this. Note the machining time is 37.66 minutes. Let's temporarily set a full depth of cut so that we can see the effect of the new island top pocketing options. We'll modify and recall the pocket process and generate full depth toolpath using the previous Z-level functionality. Let's zoom in a bit and take a closer look. Notice that full pocket toolpath is generated at each island Z-top level. Now we will enable the island top option, choosing to machine island tops at the end of each pass. We will also enable the new invert spiral direction option so that our island tops are cut from the outside in, while the pocketing depth levels are cut using a spiral inside-out direction. Regenerate the toolpath, and you can clearly see the reduction in the amount of toolpath being generated. Notice that the shelves and islands are now cut independently of the main pocket levels. We will now revert back to the original depth settings in order to measure how much time is saved when using this method. We set the depth of cut back to 0.25 and regenerate the toolpath once again. Again, we will use Show Path in order to compare the machining time of the new toolpath to the previous method. This time, we'll use Show Path at full speed. And we quickly arrive at the reduced cycle time. The new island top pocketing feature has reduced the machining time from 37.66 minutes to 26.87 minutes. This table illustrates the cost savings achieved for a range of machine tool hourly costs at a variety of batch sizes. We'll enter the initial and improved cycle times to show exact savings. In this example, we have achieved a 29% reduction in the cycle time and realized a $2,248 cost savings when machining a batch of 250 of these parts on a machine with a rate of $50 per hour. Finally, let's use ShowCut to simulate the machining of the pocket feature. Notice how the shelves and island tops are machined after the subsequent pocket level. Also, see how the island tops are cut using a spiral in direction, starting with the tool off the face. SmartCAM version 17 provides significant improvements to pocketing from solid models for SmartCAM freeform machining, advanced milling, and advanced turning. These automated pocketing improvements may now be applied to a wider variety of pocket configurations, producing more efficient toolpaths and saving both valuable machining and programming time. To receive a no-obligation trial of SmartCAM V17, please email us at sales@smartcamcnc.com. For more information on SmartCAM V17, please check our website at www.smartcamcnc.com.